today we are going to start our session with understanding velocity. In the previous sessions, we have worked with the speed and average speed. Now, today we are going to discuss the velocity. Now, what do you understand by the velocity? If I go by the definition of the velocity, it has been the rate of change of displacement. Okay, it is rate of change of displacement. Whenever I use the word rate, it refers that I am looking for the change in displacement with respect to time. So change in displacement. Or you could talk about the displacement happened for a particular time interval. So change in displacement with respect to the time interval. Or in the other words, you can simply say that velocity is the speed in a particular direction. Okay. So speed plus direction is velocity. Rate of change of displacement is velocity. Okay. Now, if I write down that 20 meters per second and I write down 20 meter per second north, which one is speed and which one is velocity? So 20 meter per second, it is just the magnitude and not the direction. So it is speed. Okay. Whereas here, along with the magnitude, I specified the direction and hence it is taken as velocity. Now, the next thing that comes up here, if I write down 20 meter per second north and I write down 20 meter per second east, does these two values are same? So my answer is no. Why? Because 20 meter per second north means here and 20 meter per second east means here, as I am considering east to be on my right side, okay, and north is upwards. So direction is different and hence the velocity is different. If you talk about the magnitude, yes, my answer is magnitude is being the same. After understanding this one, let's just talk about the examples here, that an object which is moving at 20 meter per second towards the east and has a velocity of 20 meter per second east, that I just discussed it with you. Okay. Now, there could be two cars. They have the same speed but different velocities in different directions. Again, the same thing I have already discussed with you. 20 meter per second east, 20 meter per second west, 20 meter per second north, and 20 meter per second south. All these four values are different from each other in terms of the direction and not in terms of the magnitude. But when you talk about whole as velocity, okay, so 20 meter per second east is different from 20 meter per second west and is different from 20 meter per second north and different from 20 meter per second south. I hope we are clear that these four values of velocity are different from each other. This is your homework. You will frame the differences between the speed and the velocity. We have already gone through the speed and velocity in detail. Let's just move to the further questions. Okay. So a runner runs 800 meters to east in 4 minutes and then 600 meters to west in 3 minutes. Okay. You need to find out the average speed. So how would you calculate the average speed? You can use the triangle. So average speed is taken to be total distance over total time. So we have total distance over total time. What is the total distance traveled? 800 meter plus 600 meter. Correct? Divided by, what is the total time? 4 minutes and 3 minutes. Now, do not write only the 7 minutes here. Rather than convert it into seconds. Okay. So, 70 times 60, that is 420 seconds. Okay. So what we get? 1400 meter divided by 42 seconds. Okay, which when we calculate will gives us 3.33 meters per second. That is my average speed. It says what is the runner's displacement. When I talk about the net displacement, what is the net displacement? 800 meters east and then 600 meters west. So 800 meters is taken as positive, 600 meter is taken to be negative. So we have 800 meter minus 600 meters, which will gives me 200 meters, and it is a positive. Positive refers which direction we are considering positive? East. So hence our answer is 200 meter east. Okay, I hope I'm clear with this question. Okay, I guess this question you could do as a practice question. It's your homework. Just take a screenshot of it. And now we'll be moving to our next topic, that is of the acceleration. When we talk about the acceleration, what is acceleration? See, when a car or an object moves over a surface, for an example, let's just this car is being moving in this direction. Is it compulsory that this car keeps on moving at a uniform speed or uniform velocity? It does not changes its direction. Its speed does not changes. Answer to all the questions is a big no, because we know that in our daily life when we move because of the traffic, because of the nature of the conditions of the road, okay, our speed changes, and that change in the speed, that change in the velocity is being incorporated by the term acceleration. So how do you define acceleration? It is rate of change of velocity. It is rate of change of velocity. Now just understand one thing, that rate refers with respect to time. So you are talking about change in velocity with respect to the time interval. Here you have to remember two things, that we'll be using the symbols U and V for representing the velocity. U refers the initial velocity and V refers the final velocity. Okay. Now, when you talk about the change in velocity, it is always final velocity minus initial velocity divided by the time interval. For the time interval, I am representing by delta t. Okay, what is this? This is pronounced as delta. This symbol is pronounced as delta, and combined form, in combined manner, I am pronouncing it as delta t. Okay. Now, after understanding the acceleration, let's just talk about the unit of acceleration. Because it is change in velocity by change in time, delta V is representing the change in velocity. Velocity is measured in meters per second. Time is in seconds. So it could be written as meter per second squared. So this is the unit of the acceleration. Now, when you talk about the acceleration, let's just think of this way, that because acceleration is v minus u by delta t, okay, here your acceleration could be 0, acceleration could be positive, and acceleration could be negative. Just understand when acceleration could be 0, when this whole term would be 0, when v minus u is 0, because you cannot put the time as 0 here. So v minus u is 0, which means v is equals to u, means the object when keep on moving with the uniform speed or uniform velocity, the acceleration is said to be 0. So if I'll say a car is moving at 2 meters per second uniformly, or with uniform motion, this word contains that the speed is not changing and hence acceleration comes out to be 0. Then we come up with the acceleration as a positive value. So what does that mean? When v minus u is greater than 0. Greater than 0 means positive values are greater than 0. No? Okay, so v minus u is greater than 0 or v is greater than u means when you speed up, when your speed is increasing, when your speed is increasing, then we will say that the acceleration is positive. For an example, you started from your home. At your home, your speed was 0 meter per second. You started moving in the east direction and you speed up to 2 meter per second. So what just has happened? Your speed has changed and your final speed is greater than your initial speed. Okay. So hence acceleration is being taken as positive. Okay. Then the next thing is being the acceleration is negative. When does the acceleration will be negative? When v minus u is less than 0. Correct? Which is v is less than u. Means when you brake, when you apply brakes. Now do remember that this spelling is not brake. Okay? This is brakes. When you pull the brakes, so your car or the vehicle stops. Okay? So v is less than u. At this moment, when you have attained a speed of 2 meter per second, you increases your speed to 5 meter per second and then suddenly you reduces your speed again to 2 meter per second. So what just has happened? Your speed has been reduced. Okay. Your initial speed was 5 meter per second and now it is 2 meter per second. Now pay attention here. I am using the word speed here because I am moving in the same direction. Okay. And I'm talking about the value right now here. Okay. Otherwise, I would say 5 meter per second. The velocity is 5 meter per second in east direction. Okay. So here the speed or the value, the value of the velocity has been reduced. Correct. So in that case, I'll say that the acceleration is negative. The acceleration is negative. That's what we have explained here. What is the positive acceleration? What is the negative acceleration? Do remember here, positive acceleration is being speeding up and negative acceleration is deceleration when you are slowing down, when the velocity is being decreasing every second. Okay. And do remember that if the direction changes, even then you will say the body is being accelerating. For an example, when you are moving in a circle here, when you are moving in a circle, so what is happening? Every moment your direction is changing. At these lines which I am drawing, they are representing your direction when your body is moving anti-clockwise. Okay. At this moment, its direction is this. At this moment, its direction is this. So when a body is moving in a uniform circular motion, means the value of the speed is not changing. The value of the speed is not changing. It's the direction that is changing. The direction that is changing. Okay. So even then, this motion is being said to be accelerated motion. Why? Because in nutshell, the velocity is changing. Velocity is changing when a body moves in a uniform circular motion. After understanding about the positive and the negative acceleration, we have already worked with the formula, which is A is equals to V minus U by T. V minus U measures the change in the velocity and T refers the time interval. Now let's just focus over the real life applications, okay, by using the certain examples. Throughout the class, I have already been given you an example which you can experience in your daily life. Let's just focus here. Imagine your family car is going at 50 kilometers per hour and your mom presses gas pedal, making the car speed up to 70 kilometers per hour in 10 seconds. Now just notice here about the units. It is kilometers per hour. It is kilometers per hour and it is 10 seconds. Okay, it is 10 seconds. So what you have to convert? You have to convert your seconds into hours either, or kilometers per hour into meter per second, whatever seems feasible to you. Okay, so what is my initial speed? It was 50 kilometers per hour. What is my final speed? 70 kilometers per hour. And the time is 10 seconds. And how would you convert that into hours? Okay, so that would be 10 divided by 10 seconds and 10 divided by 3600. Okay, and that will gives you 0.0028. Okay, hours. Fine. So in that case, what would be my acceleration? V minus u by t. And what is my V? 70 minus 50 divided by 0.0028. Okay. So we have 70 minus 50 as 20, then divided by 0.0028. And my answer comes out to be 7142.85. Now here my units are kilometer per hour square. Okay, this is the one way. Or the other way, what you can do, you can convert your U and V into meter per second. Now, how would you convert your 50 kilometers per hour? To understand that, just look here. How you convert 1 kilometer per hour into meter per second. So it would be 1000 meters. And hours is 3600 seconds. Okay. So what you have? 1000 meter divided by 3600 seconds. It will gives you 0.277 meter per second. Okay. So what is 50 kilometers per hour will be equals to? That would be 50 times 0.277 meter per second. So we multiply it by 50. We get 13.89 meter per second. How do you define 70 kilometers per hour? So you have 70 multiplied by 0.277 and you get 19.39 meter per second. Okay, so again using the same formula, A is equals to V minus U by T. It is 19.39 minus 13.89 divided by 10 seconds. So we have 19.39 minus 13.89 divided by 10, which is 0.55 meter per second square. Okay, I hope I'm clear with this question, how you can solve it. The better way is to do this way. And if they haven't said anything, like if the units are not written, then you can even proceed with this way. Okay. Now these high speed acceleration examples, you have to, I'll not say remember, but you must know that your family car actually moves at an acceleration of 2 to 3 meter per second square. Okay. All these are in the meter per second square. Falling object is 10 meter per second square. Okay, rocket is 30 meter per second square. Formula 1 car, many of you might be seeing the racing competitions, the Formula 1s. So it is moving at 50 meter per second square. Just imagine, even if your family car is moving at 5 meter per second square, your Formula 1 car is moving 10 times faster than that, and your jet is being almost 2 times faster than a Formula 1 car and 20 times faster than a family car. So here it is 90 to 120 meter per second square. We'll have gone through the acceleration. You understood the concept of the acceleration. You understood the formula which we have used, A is equals to V minus U by T, and how we could use it for calculating the acceleration. So that's all for today. If you have liked the way of teaching, if you have got the concept, please do like, share and subscribe. And if you have any doubts, any queries, please do drop it in the comment section below. Thank you and have a nice day.